Hello guys and welcome back to my YouTube channel. In the previous video we've looked at how you can actually build an AI system with the LangGraph. So where you understand the LangGraph state, you understand the node, you understand the edge and the graph, and you can actually build a simple graph and then run the graph. We've also seen how you can actually build a chatbot with LangGraph. Now, one interesting thing and one very important thing about building with LangGraph is understanding the state schema. Okay, so the state schema is which is the LangGraph state. The state schema is a schema that holds all the data that your graph is working with at every point in time. So you need to understand the state schema and how it works. You need to know how to create different schemas so that you can actually do a whole lot with LangGraph. So this is what today's video is all about, understanding the LangGraph state schema. All right, so without wasting much time, let's dive in. Okay, so typically this is just a simple state and a simple schema. So this is just what we have been doing. All right, so create a simple state of a type dict that is having only one key graph state, which is of type string. All right, then we'll define our node, build the graph, and then run the graph. So this is very basic. All right, so okay, this will return an error. I have not run this, so let me run this first and then run this. Okay, so and if you run this now, so this is just how what we've been doing. This is just how it has been working. So now, why do I always use type dict for my state schema? So there are other methods you can use, which are you can use the Python data class, you can use Pydantic, but type dict is always more convenient while working with LangGraph. Alright, that is why I'm using type dict. Then, what type of data does this type dict create? So let's have a look at this place. So I am creating an instance of this state, and I'm populating this graph state with yes, and I'm looking at the type of data I'm having in this state. So if I run this now, you see that once I create an instance of state, what I always get is a dictionary. So that is why it's of the type dict. All right, so it creates a dictionary. So whichever time I want to access my state, I'll be accessing the keys there as a dictionary. So that is just one of the easiest way that it works. All right. Then let's move forward. So I'm going to add more keys to the state. All right. Remember that what we did last, we only have one key, which is the graph state. Now I'm trying to do something a bit further. All right. Here now, I'm creating a state that is having three keys: goose, price, and float, and each of them have different type. This is of type string, int, and float. This means that I can pass different data to them. All right, you can pass different data. It can hold any type. It must not just be string. So at any point in time that I want to access the state schema, so I'm going to be using it as state goose to get the goose, price to get the price, and balance to get the balance. All right, so let me define a simple node. All right, so this is just a simple node. So what we are doing in this simple node is we pick the price of a particular goose, and then we subtract it from the balance, and then we update the balance with the actual balance. So what I'm trying to mimic here is maybe you are trying to make a purchase, all right, and then you have the price of the goods. You have to subtract it from the balance that you have. So this is your balance. This is the price of the goods that you are trying to buy. So you subtract it from your actual balance, and then you update the balance. So what we did there was we get the actual price, okay, and then we get the balance. That is the balance that we'll have. So I'm using state.get balance 10,000. So what this does here is, if I am yet to populate balance for the first time, then it should give me 10,000. But if I have populated balance, then it should get the actual value that is being stored in balance. So this is one way of reading values from a dictionary when you are not sure if a particular key exists in that dictionary. All right, so if you're not sure that that key exists, you're going to use .get, pass the name of the key, and if it doesn't exist, then return a default value. That is just what happens here. And then we subtract the price from the balance, and then the remaining balance we update the key balance. We build our graph. So let's run this, and then I can invoke the graph here. All right, so after invoking the graph, this is the current state. So I passed that the goose I want to buy is rice, and the price is 3540. All right, 3,540. And this is the goose rice. This is the price, and then this is the balance after subtracting 3,540 from 10,000. Okay, I can add any value that I want here, and it's going to run, and then I will get the result. So with this now, you understand that you can pass as many key as you want inside your state schema, inside while defining your schema. But ensure that you're using type dic, so it will be easier for you. You can actually access them as a dictionary. So if you want to use Pydantic, you can also use Pydantic as well, or Python data class. So all right, now let's take it a little further now. Okay, so I'm going to create another type here, a product now. All right, so this product is just, I'm defining the product, and you know that for every product, the product will have a name, the price, and then the quantity. This is just for maybe somebody that is trying to purchase something. You get to a mall and you want to buy a particular product. All right, so you have the product name, the price, and then the quantity you are trying to purchase. Now, I can also add a key and use a custom type for the schema. So it all depends on how extensive you want your schema to be and the type of data you are passing to the schema. So here now, I created a custom type, which is product, and I am adding a product in my schema, and it's having a custom type, while the balance is having a type balance. All right, so what happens there when I pick my state? Remember, my state now has two keys. All right, so in the two keys, balance is of float, while product is the instance of this product here. So for product, it will be having the instance of this, and I can now access all these other keys inside here. All right, so this is now my schema. This is now my node. All right, so from the state, I am picking the product with state product, and then I'm trying to get the balance. If it doesn't exist, populate 10,000 for me. All right, so I know that inside this product, the price of the goods is inside price. So I'm now saying balance minus product of price, so I can access this price to subtract it from the balance I have, and then I can now populate the balance back. I can now update the balance key in my state. Okay, so I build my graph passing the state, which is this state. Remember, this is a custom type, which we use as a type of one of the keys here. All right, so this is to show you that you can have multiple types. You can create your own custom type and pass it in your state schema. Run the code and can invoke, and then first of all, to invoke this, I need to create an instance of product because I need to pass that instance as product to my graph. All right. So creating an instance of product, I pass name, price, and quantity. All right. So and then invoke this, and you see the current state of the graph. So this is the current state. The product has all this. It has the name, the price, and the quantity, and then this is actual price after subtracting this price from the 10,000 that we have here. So this is how you can add a custom type to your schema. All right, now let's get to state reducer. All right, so there's something that is called a state reducer. So now, what is a state reducer? I'm going to show you something. First of all, this is just what we have been doing, just something very basic, as simple as this. Now, what are we doing here now? Okay, I have a state schema. One of the keys here is graph state, which is of int. And after, when the node is done running, I am updating the graph state by adding 1 to the current value in the graph state. All right, I pick the current value in the graph state and I add 1 to it. So let me build the graph and then let me run here. So I'm passing 1 here now. So after running this, our graph state is 2 because it picked the current state, added 1, and then updated the graph state. All right. If I passed 5 here, I'm going to get 6 because it picked this 5 and it will add 1 and it will become 6. Now, what happens here is that at every point in time, the current state is being overwritten. Now, what if you don't want your current state to be overwritten, but you want to have a series of data in your state? After a particular node is completed, you don't want the entire data to be wiped out. You just want to have a record of every data being produced while each of the states has run. So work with me. All right, so now let's do something a bit complex. This is where the problem occurs with what we have been doing currently now. So this is the problem. The problem is when we have multiple nodes, like these are 3 nodes, all right, and then this is our state, graph state of int. So in each of the nodes, we are updating the key graph state by picking the current state and then adding 1. Pick the current state and add 1. Pick the current state and add 1. All right, then we are just printing the node that is being executed. Now let's look at how our graph is. We added the 3 nodes. We went from start to node 1, then from node 1 to node 2, node 2 to node 3, then node 2 to end, and node 3 to end. Let's run this so that we'll see the graph. All right, so this is how the graph is. So a graph like this is common trick in LangGraph. So what is happening here is that we are running these 2 nodes in parallel. So these 2 nodes will be running at the same time. From node 1, it's going to call these 2 nodes at the same time, and both of them will run at the same time. All right, they will be running in parallel. Okay, so and when they are done, you see that both of them will be trying to update the graph state at the same time because it's the same function that is in both of them, so they will take absolutely the same number of time to run. So they'll be trying to update the graph state at the same time. So now let's see the problem. All right, so I'm trying to catch this error from LangGraph, invalid update error, because this is the error that will occur here now. So if I run this, you see that I'm getting this error. Graph states can receive only 1 value per step. All right, so this is the error that we are getting. If I didn't add this try and except line here, this code will definitely crash and I'll see errors here. All right, so I'm trying just to catch the error here now. All right, so it's saying that the key graph state can receive only one value per step. Now, this is to tell you what is actually happening here. It is trying to, these two nodes are trying to update it at the same time. That is why it fell into this error. So how do you solve this type of problem? The easiest way to solve it is to use a reducer while defining your schema. All right, so the work of this reducer is to now create a list of values so that at the end of every node, and that node is trying to add data, is trying to update that particular state, it's going to append the output from that node to the list of the values in that particular key in that state. Work with me so that you see what we are talking about here. So this is me defining a reducer here. This is a custom reducer. All right, so I'm going to show us how this works. Now, this add function here, what it does is, okay, I'm going to take this add function and I will define it here. So what this function does is to take two values and then add both of them together. All right, so if I execute add and I have 3 and I have 2, it's going to return 5. This is for integers. Do you understand? If I pass string, it is going to concatenate the second string to the first string. Now, if I pass a list, let's see what happens if I pass a list now. If I pass a list, I have 1, 2, 3, and I have another list here. Let's say I have 6 in this place. So let's run this now. And you see what happens now. It takes this second list and it concatenates it at the end of this other list. So this is what this reducer does. So it takes this value and it concatenates it to this. Even if this is not a single value, if I have multiple values here, it's going to do the same thing and concatenate it here. So what this function does is to take the second value and concatenate it to the first value. So it works perfectly for a list. That is what this returns function does. So whenever you are using this additional operator between two lists, it's going to concatenate them together. All right. So this is how this add function does. Okay. So all right, before I run this other code here now, I'm going to use what we did here to show us something. So I'm going to pick this and I will run it here. Um, sorry, let me take this out. I didn't copy this. All right, so and I'm going to be using this state that I defined here there. So I'm going to copy, I will replace it with this, and I need this. Okay. All right, then what happens here? Now, remember I already have this function add here. All right, so and I'm defining my state as a type dict, and this is annotated. So I am annotating the type, and what I want it to hold is a list of int. And whenever there is an update, I want it to use this add function to update the value. So that is just what happened there. So whenever there's an update, it's going to use this add function to update the value. All right, so and then this is my node where I'm trying to update this value. So whenever I run this, what it will take is this um, this new value now, which I will get by the time I take the state graph and then add it to 1, is going to be one value, and then the initial state is going to be another value, and it's going to pass it to this add function, and it's going to concatenate both of them together. All right, so we should not know that from this function, we should ensure that whatever we are passing here should be a list, because if it is not a list, it's going to return an error. All right, so this video is taking long, but I have to explain all these things so that we can understand. So I'm going to run build this graph now. So let's build the graph. All right, the graph is built, and then let me run it. Let me use this to run it. Okay, so I'm here now. So if I run this graph now, you see the first value I have here is 5. So let's run the graph. I'm getting an error. Okay, it's not in. Okay, this is where the error is coming from. I'm supposed to pass the input as a list, because now what we are having in our state graph is a list, not just a single value, but a list of integers. Okay. All right, so I'm still getting an error, so I'm going to check where the error is coming from. Okay, so this is where the problem is coming from. All right, so what I have here now is I'm getting the current state of the graph, which should be a list. So I'm supposed to process it as a list. So I want to be picking the first index in the list, which is this first value that I passed. So I want to be picking just the first index. Okay, so that was what I omitted here, because I was checking what I omitted in this line. Okay, now, and the program has run now. Okay, so this is 5, which was the value that we passed, and we did pick the value and add 1, and we are getting 6. If I passed 1 here, I'm going to get 1 and 2. I'm getting 1 and 2. So this is just how this works. Okay, so once there is an update, it runs this to update the actual value. So I can now run this, which we did before, that is a bit advanced, that have a couple of other features and values, having the node 1, node 2, node 3. All right, so okay, now all the values are in place here. So I'm going to run this. I'm going to build this graph now. So this is this graph now. Okay, so and I'm going to run the graph here. I'm passing 1 as the first value. So let's see what happens. And you see what we got. We got 2, 2, and 2. So this way, it was picking this first value and then adding 1 to all of them. Now I'm going to change something here. Node 1 should add 1. Node 2 should add 2, and node 3 should add 3. Then I build the graph again, and I run this. So, and watch, this is what we have here now: 1, 2, 3, 4. So node 1 return 2 because we're adding 1 to 1. This return 3 because we're adding 1 to 2, and this return 4 because we're adding 1 to 3. All right, so at this point now, multiple nodes can append data to the state graph. So with the help of this state reducer, which we'll define here. So there's also, if you don't want to define your own state reducer, there's a custom reducer you can use from operator. So you can say from operator import add. So this is also a state reducer you can use for here now, but I defined my own custom add reducer. So now let's look at the LangGraph messages state. We get how you can actually use the messages state comfortably. All right, so I'm importing a couple of libraries here from the LangGraph core.messages. I'm importing human message, AI message, system message, any message. Now, this any message is a type that was defined by LangChain that talks about any of the messages that they have defined. So when you say any message, that means it can accept system message, AI message. This is a list of messages. We have chat message, function message, tool message, AI message, chunk, etc. Then from LangGraph, we are importing the add message and the messages state. Okay, so this is the messages state we are trying to define and show how it works. LangGraph defined a custom message reducer, add message reducer for their messages state, which is this add messages. So what this function does is, unlike our add operator, this message appends any message to the list of messages. Okay, it appends any message. It must be from any message. So if the message is not from any message, it's going to throw an error. So it appends any message to the list of messages. So this is a custom messages state, not the one from LangGraph, but this is the custom messages state. But this is just the structure of how this messages state is being defined. All right, it has one key messages. Okay, and then it has a list of any messages. So it's a list and it can contain any messages, which means it can contain human message, AI message, system message, and so on and so forth. And this is the custom message reducer that appends any message to the list of messages. All right, so let me show us how this thing works now. All right, let me show us how this add messages work. Let's say we have a list of messages here. This is initial messages. We'll have human messages, AI message, human message, and then we have another list containing just one message, AI message. All right, so let me run this, and then I process add messages. I am passing this initial message and new messages. Let's see what happens. So you see that it appended this last message to this list. So this is how this add messages reducer works. So this is just how it works. Okay, so once it sees a message, it appends it the um, to the first message. So it takes two values, the initial message and then the new message, and then it can append both of them together. All right, so let's now see how this plays out comfortably in a chatbot. Okay, so we'll make our importations. So okay, we'll run this and then we're going to run this. So this is our LLM and then the system message. So we'll run this as well. So, and as this is running, this is the function for the LLM call. So it takes the list of messages in the messages state. Okay, it takes the list of messages in the messages state, invokes the LLM, and then updates the response back to the list of messages. So this is just what this does. Okay, so by running this return function, it now updates this using the add message reducer. Okay, so we run this, and then we can actually invoke this now. So when we invoke this, we are passing these initial messages. Now, this initial messages is this list now that we have here. Remember, it has different messages. This is like a conversation. Okay, so this is why I'm using this, so that you understand how you can pass a conversation to the LLM with the actual message that you have, and then it will be able to give you a response. So the LLM will be seeing this last message here, and it's going to respond to it. So, which is this response that we got here. But then we still have all the other messages here because they were all here. All right, good. So if I want to access this last message here, okay, I'm going to access it from, let's do it gradually. So result messages will give me the list of messages that I have here. Now, to access this last message, I will pass -1 so that I can access this last message. And to now get the content, I add dot content, and then I'll be able to get the content. So that's what we are trying to do here, to print the content from the results. All right, and this was the content that we got. Now, at this point, it was able to respond to my name because at the list of messages here, my name was passed at some point. All right, so this is just how you can get a response from your AI, um, and so this is how the messages state works, and then you'll be able to get the list of messages, and you'll be able to access them one after the other. All right, so if you like the video, give us a thumbs up, and subscribe to the YouTube channel. We'll have tons of video coming for you on building AI agents with LangGraph, LangChain, and a couple of other platforms. Thank you very much. Meanwhile, keep coding.